Welcome to Study Loop.
Want to see, well, we have two blocks, so we just want to see, let's draw the free body diagram. Going up would be force normal, going down would be force of gravity, or we can say force of gravity in this case. And then this box here represents the two masses. So here it would be the sum of forces in the y direction equals MAY. Now MA sub y, this is going to equal 0 because the system is in translational equilibrium. So we can say that this is going to be equal to force normal minus force of gravity. Oh, my apologies. And so we can say that the force normal would be equal to the force of gravity. And this would be equal to mg. Now, both of the blocks are 10 kilograms each. So we have a total mass of 20 kilograms. And then times the acceleration due to gravity, 9.8 meters per second squared. And we find that the force normal in part A is going to be 196 newtons. Now, for part B, let's get a new workbook. For part B, we're going to say that the subscript 1 is for the top block. Subscript 2 is going to be for the bottom block. Now, we can, again, draw the free body diagrams. This will be block 1. And going up here would be force normal. We can also say that this is going to be the force of block 2 on block 1. And then going down would be the m sub 1g. Another free body diagram for the block 2 on the bottom. Going up, we have force normal sub 2, and then going down would be, of course, the weight, so m sub 2g, and then a secondary force, F sub 2, 1, the force of block 1 on block 2. So at this point, we can again say that the sum of forces in the y direction is going to be equal to the force sub n1 minus m sub 1g, and this is going to equal 0. So we're trying to apply the sum of forces in the y direction to the first block first. And so we can say that force sub n1 will be equal to m sub 1g. At this point, we can say that f sub n1 is going to be equal to f sub 1, 2, which would be equal to f sub 2, 1 due to the Newton's third law of motion. And this is going to equal 10 kilograms times 9.8 meters per second squared. And this is giving us 98 newtons. So at this point, we can say that the sum of forces in the y direction for the second block will be F force of normal 2 minus mass sub 2g minus force sub 2, 1. And so this is going to equal 0 because, again, the system is in translational equilibrium. Therefore, F sub n2 would be equal to F sub 2, 1 plus the weight m sub 2g. And so we can solve F sub n2 would be equal to 98 newtons plus, and then here it would be 20 kilograms multiplied by 9.8 meters per second squared. And this is giving us 294 newtons. So this would be our final answer. So this would be the magnitude of force normal 2, magnitude of force normal 1. That is the end of the solution. Thank you for watching.